Hi viewers, welcome to GMATH Max. In this video, we are going to see the fifth problem in the exercise 1.2. Okay, before that we have to see about disjoint sets. Disjoint sets and overlapping sets. Okay, disjoint and overlapping sets. Okay, what is disjoint sets? Two sets A and B are said to disjoin if they don't have common elements. Okay, see, if this is a set A and this one is set B, means here there is no common parts, okay, from the set A and B. It is disjoint. Okay, so that these two sets are called as disjoint sets. If we can see that example using that element here. If set A has 1 2 3 and the set B has some A B C, okay, see, there is no common element, they don't have any common element. Okay, so that these two sets are disjoint. How do you find common element? How do you find the common element? A intersection B. This one is called as a intersection. Here this one is, the symbol is the intersection. Okay, intersection means it is, you have to write the common elements of the two sets, intersection of A and B. If it is any common in between A and B, you can collect it. Okay, that is A intersection B. If A intersection B is 5 means there is null set, empty set, there is no number. Okay, means implies these sets are disjoint sets. If A intersection B is 5 empty set, then we can say the set A and B are disjoint sets. Okay, and then overlapping sets. What is overlapping sets? How do you identify? How can we identify this? Yeah, overlapping sets. See here, this is the set A and here the set B is overlapped in the set A. So this is already in A, this is the set A, this B is overlapped in A. So here, this is the common part of the two sets A and B. Okay, so if you find, see here, A equal to some, for example, 1 2 3 and the set B is equal to some 2 3 some 4 5 like that is there, means then whether it is a overlapping or disjoint sets, you have to find out A intersection B. A intersection B means if there is any intersection, means common elements or common parts are there in the set A and the set B. Okay, so what are the common elements are there? Common element in the sense that element should be in A as well as it should be in B. Okay, so here 2 3, here also 2 3 is common. Okay, here there is a common element, so it is not equal to 5. Okay, it is not an empty set, it has some element. Okay, so in between A and B some relation is there, 2 and 3 is common. Here some parts are there. Okay, for the sets and B, set A and B. Okay, so that we can say this, if A intersection B is not equal to 5, we can say it is set A and B are overlapping sets. If the set A and B, A intersection B is equal to 5, then the set A and B are disjoint sets. Now you can understand what is a disjoint set and what is overlapping sets. Now we are going to see the exercise problem. Fifth one, first division. First division, A equal to FIAS and the set B equal to ANFHS. Okay, they have asked whether the sets are, which pairs of sets are disjoint or overlapping. Disjoint or overlapping. So we have to find out disjoint or overlapping. Okay, So for disjoint or overlapping, you have to find out that A intersection B, intersection of given two sets. Okay, this is called intersection. Symbol of intersection is this one. So A intersection B equal to, how do you find A intersection B? If there is any common element in both sets, we can collect and write inside the set notation. That is A intersection B. Okay, here F is there, here also F. So F is common in both set. அடுத்தது I is not there, so I is not common, and A is in both set, so A is also common. S is also in the both set, so S is common. Okay, so A intersection B has some value, it has some element, so which is not equal to 5. Therefore the sets A and B are, the sets A and B are overlapping. It is not disjoint, it is overlapping. Understand? The next one is second question. We can see the second question. Second subdivision is C equal to set of all x such that x is a prime number. X is a prime number and x is greater than 2. And the set D equal to x such that x is an even prime number. Even prime number. Already we have seen all these things about prime number in the previous video. Okay, here now we have to write these two sets in roster method. It is given in the set builder form. Okay, x is a prime number and x should be greater than 2. What are the prime numbers? Now we can see in the number system. Prime number starts from 2 and the next prime number is 3 and the next one is 5 and the next 7, 11. It will go on up to infinity in the number system. Okay, the first prime number 2 is only the even prime number. Other than this 2, all the rest of the prime numbers in the number system are odd number only. Okay, so even prime number means only 2 is the even prime number. Okay, so here C, the set C equal to x is a prime number and x should be greater than 2. X should be the prime number, but that prime number should be greater than 2. So this 2 we can't include in the set C. So rest of the prime numbers we can write here 3, 5, 7, 11, etc. It will go on up to infinity. It is an infinite set. Okay, and then D equal to, set D equal to, x is an even prime number. Only one even prime number is there in the number system. It is nothing but 2. Okay, so we can write this 2. Now we are going to check whether the given two sets C and D are disjoint or overlapping. So here disjoint, first for that you have to find out C intersection D, intersection of two sets. Okay, C and D. Here 2 is here so many elements are there, but there is no 2. Here only 1 2 is there, here there is no 2, so there is no common elements in the sets. So C intersection D is a empty set. So that is, which is equal to 5. Okay, empty set means this one is C and D. There is no relation between C and D because there is no common element. Therefore, the sets C and D are disjoint sets. Disjoint sets. Okay, so now we can see the third subdivision of this fifth problem in exercise 1.2. Okay, the third question is the set E equal to x such that x is a factor. X is a factor of 24 and then f equal to x such that x is a multiple of 3. X is a multiple of 3 as well as x is strictly less than 30. Okay, so given in set builder form, you have to write it in the roster form. Okay, so E equal to set of all x is a factor of 24. What are all the factors? Any number which divides 24 exactly without any remainder, that numbers are called as a factor. Okay, what are the numbers will come? 1, 24 and then second table 2 12s and then third table 3 8s, and fourth table 4 6 are. At the fifth table we can't divide, sixth table already is there, seventh table is, so only these are the factors of 24. So here if you write it in order 1 2 3 4 6 and 8 and 12 and 24. Okay, and the set f is equal to, x is a multiple of 3, multiple of 3, and second condition is it is strictly less than 30. Multiple of 3, it starts from 3, then second it is a multiple of 1 time, then second 2 times means 6, and 9 12 15 18 and then 21 and then 24 and then 27 and then 30, but strictly less than 3, so we should not include this 30. Okay, up to 27 only you can write. Okay, now we have written the sets E and F in roster form. Now we are going to check whether it is both sets are disjoint or overlapping. To find that, here you have to find out E intersection F, intersection of these two sets. Intersection, how do you find that intersection? You have to find the common elements of the two sets. What are the common elements are there? Here 1, here there is no 1. Here 2, here there is no. Here fully multiple of 3. So here if there is any multiples of 3, it will come as a common element. See here 3, here also 3. So you can write 3 is a common. Here 6, here also 6. So 6 is common. 9, there is no 9. Here 12, here also 12. So 12 is common. And 15 is not there. 18 is not there. And 21 is also not there. And then 24 is also the common element here. So here it is common. So this is not equal to 5. It has some element, intersection. It has some common element. Therefore, the sets A and B, the sets E and F are overlapping. I think you have understood these three divisions in the fifth question. If you like this video, please like, share and subscribe.